I'm going to be doing problem number 9, which reads, a crate of eggs is located in the middle of a flatbed of a pickup truck as the truck negotiates an unbanked curve in the road. The curve may be regarded as an arc of a circle of radius 35 meters. If the coefficient of static friction between crate and truck is 0.6, how fast can the truck be moving without the crate sliding? The first thing I did was I drew a diagram of the truck moving in a circle. So we have the crate on the top of the truck, and the radius of the circle is 35 meters. The next thing I did was I drew a free body diagram with our coordinate system. So the up direction is positive for the y forces, and for the x forces towards the center of the circle is positive. And then the forces acting on the crate are the normal force acting up in the y direction and the force of gravity acting down in the y direction. And in the x direction, we have the frictional force towards the center of the circle. Summing the forces in the y direction, we have the normal force times the mass, the force of gravity is equal to the mass times the acceleration. But since there's no acceleration in the y direction, we can just say that the normal force is equal to the mass times the gravity. Now, summing the forces in the x direction, we have the frictional force is equal to mass times velocity squared over r. And we can substitute in mass times gravity for the normal force. So we have the coefficient of friction times mass times gravity equals mass times velocity squared over r. We can cancel out the mass to get velocity squared equals r times the coefficient of friction times gravity. And then solving for v by plugging in the known values, we get v is equal to 14.3 meters per second. So any value below and including 14.3 meters per second will have the crate not slipping.